Kia ora koutou. I'm going to work through this differential equation question from the Wellington College Scholarship Calc exam. So it's reasonably straightforward. I think you have to, as usual, keep track of what's a constant and what's a variable, and you have to be really confident with your partial fractions, which is why I put this question in the exam. Partial fractions problems do come up in scholarship calculus, and if you're not fluent with the technique, go watch my partial fractions 1, 2, 3, 4, and 5 videos. But actually, for scholarship, you probably really only need the first couple. If you're doing Cambridge A-level, you need to know all of the different patterns. But the pattern in this one is the first and most basic of the patterns, where we have two linear factors. Okay, so let's have a look at what we've got. Right, we've got a model for the spread of an infectious disease within a population, and it can be described by this DE. T is the usual number of days since the first infection. N is the total number of infected people, so that's my variable. Then we've got constants, N infinity, N naught, and K. Now the only interesting thing to note just at the start is that if you look at the equation, N naught is not in there. So that's going to be something we get by substituting in T equals 0. And our job is to find a general solution to this DE explicitly for N. So that means you really want to have N on one side of the equation. So let's get going. We've got dN by dt is equal to Kn times 1 minus N over N infinity. Now, straight away when I saw that, I cleaned up the second factor into one fraction, like this. And I'm going to separate the variables, and the only thing I'm going to leave on the right-hand side is K. So what do we get? Well, we're going to have N infinity over N times N infinity minus N dN is equal to K dt, as we always do, and we're going to integrate both sides. Now on the left-hand side, we're going to do some partial fractions work first, because we can see that we can't easily integrate that. So we're just going to fix that up and write it as the difference of two fractions. So we've got this. It's going to be big A over N plus big B over N infinity minus N. Now cross multiplying and working with the denominator gives me this. So this, by this stage of the year, guys, this should be feeling really easy. If it's not, go do some partial fractions work or just some revision. And now we're going to substitute in let N equal N infinity, because that's going to let me zero out this factor. So now we have N infinity is equal to A times 0 plus B times N infinity. That means that B has to equal 1. So that's good. And now I'm going to do the last bit by substitution. I'm going to put this back in here. N infinity is equal to A times N infinity minus N plus N, and you can see that in order to have, we've got negative AN plus N plus A in infinity, we must have A is equal to 1 as well. Right, so now we're good to rewrite that fraction, and I'm going to write that straight into the integral. Just get rid of this and get some more space. Okay, so my integral is going to be, what's it going to be? 1 over N plus 1 over N infinity minus N dN is equal to KT plus C. If you're feeling nervous about those partial fractions, it's really, really easy to do a quick check that that all works out. So it's probably worth doing if you're concerned that you haven't got it right. Okay, so on the left-hand side, we get the natural log of N minus the natural log of N infinity minus N. I need the negative sign because of the chain rule, is equal to KT plus C. I'm going to write that as one log using my level 2 log rules. And we know also that in here, N is going to be a positive number because it's the number of people infected. And we know that it is always going to be below the maximum number of people. So those two things are both going to be positive, and that means that we can ditch our absolute value signs, which is not a big deal, but it's just nice to get rid of them. So we've got n over n infinity minus n is equal to kt plus c, and I'm going to substitute in t equals 0, and we know that at t equals 0, the number of infected people is n naught. So that gives me ln of, what am I doing? Let's have a wee look. So ln of n naught over n infinity minus n naught is equal to c. Right, now we're going to put all of that together. We're going to take this, we're going to put it into here, and then we're going to make n the subject. Obviously there are different ways to go here, but I just did this and it worked out pretty quickly. So that's putting in my constant. The next thing that I'm going to do is e to the power of both sides. So we have n over n to the infinity minus n is equal to e to the kt plus the natural log of this. Now we're just into some algebra. This can be split up as follows. I'm doing extra steps in here because there'll be some of you watching who are rusty on that, right? If you are, you need to go over your Merit Level 3 integration work. This part here is going to become n naught over n infinity minus n naught times e to the kt. And here we've got n over n infinity minus n. So just doing a little bit of rearranging. What do we get now? Well, we're going to have n is equal to n naught over n infinity minus n naught, that's all a constant, times e to the kt times n infinity minus n. We need to rearrange and bring this bit, add this back to both sides. Pretty sure most of you will have stopped watching by now, but hopefully someone's still out there. Right, we've got this n into 1 plus n naught e to the kt over n infinity minus n naught is equal to n naught n infinity e to the kt over n infinity minus n naught. Now it's still a bit ick, so I'm going to clean up this side and get a single fraction, n naught minus n naught plus n naught e to the kt over n infinity minus n naught. This is a very boring video, sorry, but there you go. The week before the exam, so hopefully you don't care. Now I've got common denominator. I'm going to times both sides through by this, and that's going to give me an expression for n. So n is equal to n naught n infinity e to the kt divided by n infinity minus n naught plus n naught e to the kt. That was fine to get it to there. A nicer way, and one that's come up in other scholarship questions, is just to do one last step. So it wasn't a show that question, but it could have been. We can also divide numerator and denominator by e to the kt, and that would give me this. Okay, so this really is just one big algebra workout. There we go, really long and boring video. Thanks for watching. 9.5 minutes of pretty much merit level DE stuff really, except for the partial fractions. Okay, so make sure that you've gone over those before November the 20th. Thanks for watching. I'll do some of the other ones later on.